In this video, I'm going to be talking about properties of numbers. Real numbers, complex numbers, rational numbers, irrational numbers, all types of numbers. Okay, first, rational numbers. Rational number is a type of number that can be written as the ratio of two integers. Okay. So, an example of a rational number would be like 2/3, maybe 6, because you could write that as 6 over 1 or 60 divided by 10 or something like that. We could write like maybe the square root of 100 because that's 10, and you could write that as 20 divided by 2 or something like that. Let's see. Oh, another one, decimal type things. 0.215, because the decimal ends, the terminating decimal will be a rational number. And maybe 0.33. No, I already. Oh yeah. The 2/3, so that's 1/3. Okay. I'm not generally a big fan of the overline to indicate that the decimal pattern is repeating, but in this case it indicates it goes on forever and it has a pattern, therefore it's going to be a rational number. And some examples of irrational numbers. I think the first irrational number that they discovered was pi, right? Because they knew about circles. You can envision the Greeks or Indians or Chinese or all the different people that discovered this kind of independently. They've got a circle and it's got some radius and it's got some circumference, right? And there's a ratio there. The bigger the radius, the bigger the circumference. And so they try to figure out what is that ratio, right? And that ratio we know now is pi. All right, I lost myself. There's a disruption. And okay, so basically, they discovered the ratio of the circumference to the radius is pi. Okay, this is an irrational number. For a long time, they thought that pi was 22 divided by 7, because we know that pi is about 3.142 or something. And if you go in and grab your calculator and type 22 divided by 7, you'll be surprised that it is very close to pi. Okay, but eventually, I'm sure they made some really large circle and started measuring, and they realized that that was off. Okay, and pi is an irrational number. So let me write some other ones for you. Okay, now the square root of 2 is irrational. Maybe I'll prove that for you in a different video or something. And moreover, the square root of any number that is not a perfect square will always be irrational, which is something I'm not going to prove for you in a separate video, but it's true anyway. So square root of 9, we know that's 3, that's a rational number, but the square root of 10 is not a perfect square, square root of 10 is irrational. Okay, what's another one? Let's see. Oh, also from this class would be e. E is not a rational number. The true definition of E is something that's probably best left for a calculus course, but I'll tell you right now, it's not rational. It does not have a terminating or repeating decimal. And if they asked us which of the following numbers are irrational, okay, well, that's kind of tough to say because you need to determine if it was rational. There aren't really criteria for being irrational. I suppose besides this one right here. Okay, this one is definitely irrational because it's the square root of a number that's not a perfect square. That's the one criteria we have. But we also know that pi is not rational and e is not rational, so there are other ones out there. Okay, and this one is irrational. Okay, the square root of 9 pi is 3 times the square root of pi. And 3 is rational, but, pi is not a perfect square, therefore its square root is not going to be a rational number. So this one is also irrational. Okay, 0.66666, and, repeating, we know that's 2/3. Okay, 2/3 is the ratio of two integers, therefore it's rational. Okay, and this one on the right, this 2.123456789, this is a rational number because the decimal expansion just ends. It's just it stops. And if we don't have a ... or an overline or something, well, then we know that it's rational. All right, so if I were to ask you which of these are rational, well, the square root of pi squared is equal to just pi, and we said earlier that pi is irrational, so that's not one. 22 over 7, not a perfect square. Okay, that's not going to be a rational number. 25 over 9, though, these are each perfect squares, so maybe I could kind of use one of the square root properties we looked at earlier in the year and say that this is 5 divided by 3. This is the ratio of two integers. This is rational. Okay. Here I've got an example of questions about some positive integers. Okay, we know that positive integers are like 1, 2, 3, 4, 5, you know, like 26, but not 26 and a half. Okay, things like that. And we're going to have two positive integers with a being the bigger of the two. Which of the, or when are these positive integers? Sometimes, always, never. Now this is the type of question that I saw on a particular standardized test that was on the computer. It was a college algebra test, and that I took last year. And what you had to do is you had to go in and click in the box for sometimes, always, or never. And I think it just discounted as one question. I don't know if you could get like half credit, or I don't know what the deal was with it. They weren't very forthcoming about how the test was scored. They just gave you a score at the end and, you know, told you if you passed or not. And what we're going to do is I'm just going to kind of show you how it is. Okay, if I have two positive integers and I add them together, I'm definitely getting a positive integer back, right? Now, if I take a minus b and a is the bigger one, well, that will always be a positive integer. Oh, man, okay. I'll just say that had I said b minus a, that would have been never, right? Because b is the smaller one, meaning that, you know, I'm subtracting smaller minus bigger, and it would go negative. Okay? A times b, always going to be a positive integer. A divided by b, well, maybe, say a was like 9 and b was 3. Okay, that could be a positive integer. But if a was 10 and b was 9, 10 divided by 9 is not an integer. Okay. B divided by a. Well, if b is smaller and it's positive, that means it's, you know, at least 1. That means that this can't be an integer. This will never be an integer. And then a to the b will always be an integer because you're just going to take a positive number to a positive number power. And that'll just be, you know, that'll be another positive whole number. So that's an interesting type of question that I have seen before. All right, the next thing I need to talk about is real versus imaginary numbers. Okay, remember that I is an imaginary number. All numbers that y'all know of are complex numbers. Okay, but, you know, real versus not real, basically. Okay, a real number has no i's when it's, you know, in its fully simplified form. Okay, and an imaginary number is going to have some i's. So, for example, like, you know, what if we were to look at I squared divided by 5? Well, you all know from earlier in the year that I squared is -1. -1 over 5 is the ratio of two integers, and it has, okay, so it is rational, yes, but it's not imaginary, it's real, because it has no i's. What about the square root of 9i squared? You might be like, oh, okay, yeah, this is just going to turn into a real number because it's I squared, right? So what you would do is you would take the square root, you need to make this -9, which is the square root of 9 times the square root of -1, which is 3 times I. Wait, that has i's in it. This is not real. There's going to be a few others in your note packets that I'm going to go back through and do as examples, but this is the type of stuff that you need to know for the quiz next time. And that's all I got for you today.